So I've always heard that when a fuel pump goes out, it's because it's got a bad winding or a dead spot on the commutator or something, and that hitting it with a hammer just sort of moves the rotor just enough it makes contact again. And this one seems to be bucking that trend, because yes, hitting it with a hammer got it going again, but if you look in there you can see some of the fins of the impeller, and I can't get those to move very much with a screwdriver, suggesting this thing is locked up properly solid. So I'm curious to see what's in it. So I've taken the little filter muffuxet off of it, and I've taken it out of this over-engineered screw-in German pump holder muffuxet, which was a pain to get out. And yeah, so the whole thing's crimped together, which makes it a little difficult to take apart. So I'm just going to cut around it here with a hacksaw, and I will be back to you in a moment. Kind of pressure relief holes. Weird. Okay, so here's that impeller. You can see it's not completely locked up. It doesn't spin very well. Also noticing those fins are not evenly spaced. That's odd. Wonder if there's a good reason for that, or if they just were having some trouble with their CAD program that day and decided, ah, screw it, so long as it's balanced it'll work. Okay, well that end does not want to come apart. Interesting. Guess I'm cutting the other end open then. Oh, never mind. Fine then, make a liar out of me. See if I care. Okay, so yeah, there's a gear rotor pump in there, like an engine oil pump, and I notice when I turn the shaft, that oil pump ain't moving. That gear rotor isn't moving. There's screws coming through here, probably from the other end, so I think I need to open up the other end of this pump. Okay, done this right. This should just pop right off, he said, right before it didn't. Oh great, I got the ring off. Yep, that's what I was trying to do. So here's the end bell of it. Looks like gasoline goes all through this motor to cool it, so that's nice. Brushes look to be in good condition. Springs are good. Nothing wrong there. The commutator should just pull right out. Yeah. Commutator is, ooh, wow. Real ugly on one side. That is burned out like crazy. So with the armature out of the way and a bunch of T10 Torx removed, you can see the gear rotor from both sides. So now I think I just need to pull that apart, because this clearly is what jammed. Okay, as I pulled it apart a little more, I found two more of these little copper pieces. I still have no idea what they were for, but they were in there. I also found this spring and ball assembly that was in between these two parts on the top. It's not an anti-drain back valve for the fuel. As near as I can tell, it's some kind of pressure relief, so that if this got blocked up, where the gas was supposed to come out got blocked up, it could come out through this little hole here and relieve internal pressure. So if your fuel pump or your fuel filter got clogged up, you wouldn't burn out your pump. Oh, I think I figured out where those little pieces came from. They're the same width, so you can see here. If it'll focus. There we go. So yeah, those little pieces, turns out they're the same width as the commutator bars. And there's a little ring around the end. So I'm starting to think this wasn't machined down this far from the factory. I mean, obviously it wasn't machined down that far, there's no copper left. So it looks like this commutator just got eaten all to hell, and those little pieces came off this end here. So yeah, all I can figure is that when I hit it with a hammer, I did in fact shake this to the point where, you know, the brushes were someplace they could make contact again, and that got that going, but it also knocked these little pieces of copper around inside, so that when I unhooked it from the battery and then hooked it up again while we were trying to drain the tank, one of those managed to fall into here, and that stopped the whole thing right up. So yeah, interesting. I had no idea this was a two-stage pump. And yeah, looks like cause of death was some pretty extreme wear on the commutator. Funny. So if you're not familiar with a gear rotor sort of pump, let me show you here how that works. Basically you've got sort of a planetary gear arrangement almost that goes around in here like this. As you can see, the tips of it are always touching. Must be some pretty tight machining tolerances going on here, but yeah, so if you've got it turning like that, on this side you've got openings. You've got these chambers sort of opening up, and so as those open up, you've got a slit in this side of the plate that goes over this, and so fluid is drawn into those. So as this keeps turning, these openings that have gotten bigger here start getting smaller, and the fuel can't get out because, well, those teeth are right up against it there, and so it has to go somewhere, and so it goes through another hole in the plate and it comes out. Pretty slick. So for a better look here, I put this sort of pump assembly back together here. So you can see how those chambers are getting larger as it goes past that window. And then, if I can get the light on it here, they're getting smaller as they go past this one. So it's drawing fuel from down here and it's forcing it out up here. So yeah, I'm not entirely certain why it had the secondary pump on the bottom. I can only assume it was to you know, just sort of draw the fuel in through the sock a little quicker maybe. I don't know. Also worth noting, these end plates are not plastic. They appear to be some kind of ceramic. So that's interesting. Might just be something about the tolerances needed to seal against these surfaces in here. Actually blowing bubbles the other way.